in a wave of modern manufacturing. Precise and efficient material cutting technology is the key to driving a leap in productivity. I'm teacher Zhang Wei. Today, together we will study Project 2 of Advanced Manufacturing Technology of Welding Structures. Basic knowledge of plasma arc cutting and blanking. This technology, with its high speed, high precision, and wide adaptability to materials, has become a shining star in the field of metal cutting. In this lesson, we will mainly study the following content. First, let's understand an overview of plasma arc cutting and blanking. Plasma arc cutting, in simple terms, is the process of using a high-energy density plasma arc and a high-speed plasma jet to blow away molten metal from the kerf, thereby forming a continuous cut. Its core lies in generating high-temperature plasma through arc discharge. Under the action of high-speed airflow, this plasma forms an extremely hot and concentrated cutting jet, which can rapidly penetrate and cut various metal materials. Next, let's study the characteristics of plasma arc cutting. The characteristics of plasma arc cutting are that it can cut various metals that are difficult to cut by oxy-fuel cutting, such as stainless steel, aluminum, and copper. When cutting metal materials with a thickness less than 16 millimeters, the speed of plasma arc cutting is relatively fast, about 5 to 6 times that of oxy-fuel cutting. The cut surface of plasma arc cutting is smooth, with little thermal deformation, making it suitable for processing various formed parts. The kerf width and bevel angle of plasma arc cutting are relatively large, but by using special cutting torches or processes, a nearly vertical cut surface can be obtained. In terms of cutting thick plates greater than 50 millimeters, plasma arc cutting is not as capable as oxy-fuel cutting. The edge of the kerf produced by plasma arc cutting basically avoids the carboized hardened layer generated by oxy-fuel cutting. However, the disadvantage of plasma arc cutting is that as the cutting thickness increases, the kerf tends to become narrower at the top and wider at the bottom, forming a trumpet-shaped phenomenon that becomes more serious. Next, let us study the structure of the plasma arc cutting torch. The tungsten electrode is one of the core components of the plasma arc cutting torch. It is made of tungsten wire, has extremely high melting point. It can remain solid at high temperatures. Gas is the medium used in plasma arc cutting. Common gases include air, oxygen, and nitrogen, which are used for cooling and for blowing away molten metal. The nozzle is the outlet of the plasma arc cutting torch. It concentrates and directs the plasma arc toward the workpiece, ensuring cutting accuracy and efficiency. Cooling water is used to cool the torch and the tungsten electrode, preventing overheating and damage, while also improving the stability and quality of the cutting process. The plasma arc is the high-temperature, high-energy arc produced by the plasma arc cutting torch, used to melt the metal and blow it away from the kerf. The workpiece is the material being cut, usually various metals or certain non-metallic materials. The thickness and material of the workpiece will affect the cutting parameters and techniques. The high-frequency oscillator is used to generate high-frequency oscillating current. To initiate the arc and stabilize the arc, in plasma arc cutting, the high-frequency oscillator is an indispensable component. What are the classifications of plasma arc cutting methods? Let's learn together now. Plasma arc cutting methods can be classified into 2 major categories according to the type of plasma arc: transferred plasma arc cutting and non-transferred plasma arc cutting. In transferred plasma arc cutting, The arc transfers between the electrode and the workpiece with concentrated energy suitable for precision cutting. In non-transferred plasma arc cutting, the arc does not transfer, making it suitable for thick plates or special materials. What are the process parameters of plasma arc cutting? Let us continue to study further. In plasma arc cutting, the type and flow rate of plasma gas are key parameters. Pure nitrogen or nitrogen mixed with argon is commonly used, which is economical and ensures quality. A mixture of 65% argon and 35% hydrogen, due to the high thermal conductivity of hydrogen, enhances arc constriction and improves cutting performance, especially suitable for plates thicker than 70 millimeters. The nozzle orifice diameter should be determined according to the thickness of the workpiece and the type of plasma gas selected. For thicker materials, the nozzle orifice must be correspondingly larger. When using an AR plus H2 mixture, the nozzle orifice can be slightly smaller. When using N2, it should be larger to ensure cutting effectiveness and stability. Plasma arc cutting requires a power supply with relatively high open circuit voltage, generally not less than 150 V. If the open circuit voltage is too low, the increase of cutting voltage will be limited, which is unfavorable for cutting thick workpieces. A higher open circuit voltage ensures the stability of the plasma arc and cutting efficiency, and is an important performance indicator of the plasma arc cutting power supply. Cutting current and cutting voltage are two important parameters that determine the power of the cutting arc. The selection of cutting current should be based on a nozzle orifice diameter D. The approximate relationship between cutting current I and nozzle orifice diameter D is I equals 30 to 100 D. This relationship is important for a given material and thickness of workpiece to ensure effective cutting. Cutting speed should be determined according to plasma arc power, workpiece thickness, and material, under the same cutting power. Since aluminum has a low melting point, the cutting speed should be faster. Steel has a higher melting point and slower heat dissipation, so the cutting speed should be slower. Copper has good thermal conductivity and fast heat dissipation, so the cutting speed should be even slower. The distance from a nozzle end face to the workpiece surface is called nozzle height. This distance affects the cutting effect and efficiency of the plasma arc. As nozzle height increases, the cutting voltage of the plasma arc rises, power increases, and better cutting quality and efficiency can be obtained. What are the safety protection measures for plasma arc cutting? Let's learn together now. 1. Anti-electric shock safety measures. The open circuit voltage of the power supply used in plasma arc cutting is relatively high. During use, reliable grounding must be ensured, and the torch and hand-touching parts must be reliably insulated. If the start switch is installed on the handle, the exposed switch must be covered with an insulating rubber sleeve to prevent direct hand contact. The radiation intensity of the arc light is strong, consisting mainly of ultraviolet radiation, visible light radiation, and infrared radiation. During manual cutting, the operator must wear a face shield and gloves, and the neck must also be protected, in addition to a dark lens. The face shield should preferably be equipped with a lens that absorbs ultraviolet rays. During automatic operation, protective screens can be set up between the operator and the work area. In plasma arc cutting, underwater cutting can be used, utilizing water to absorb light radiation and effectively reduce arc light damage to operators. 2. Dust and fume prevention measures. Plasma arc cutting is accompanied by a large amount of vaporized metal fumes, ozone, and nitrogen oxides. Therefore, the workplace must be equipped with good ventilation facilities. An exhaust device should be installed under the grid work table to ensure air circulation in the work area, reduce the accumulation of harmful substances, and prevent operators from inhaling excessive harmful gases. 3. Noise prevention measures. Plasma arc cutting produces high-intensity, high-frequency noise, especially when using high-power plasma arc cutting, where the noise is greater. When the cutting current is below 100 A, the noise is relatively low and has little impact on the surrounding environment. Above 100 A, the noise increases accordingly. Plasma arc cutting requires a high-frequency oscillator to initiate the arc, which has certain hazards to the human body. The arc starting frequency is preferably selected between 20 and 60 Hz. The high-frequency oscillator should be equipped with a shielding cover, and the workpiece must be reliably grounded. After the main arc is ignited, the power supply of the high-frequency oscillator should be immediately and reliably cut off. When using high-frequency sparks to check electrode alignment, the time should be minimized to reduce harm from high-frequency electromagnetic fields to the human body. Any advanced technology cannot be separated from safe operation and maintenance. 1. Maintenance of the cutting machine. It is necessary to regularly check whether the torch has water leakage or gas leakage faults, and to replace vulnerable parts in time to ensure normal operation of the torch. During long-term use of the plasma cutting machine, vulnerable parts will gradually wear out, so they must be regularly inspected and replaced to ensure stability and safety. 2. Maintenance of the control box. Regularly remove dust inside and outside the torch, and carefully check the contact condition of each relay contact to ensure normal operation of the control box. Regularly clean the spark gap of the high-frequency oscillator, the step-up transformer, the high-frequency transformer, and other high-voltage circuits to prevent reduced insulation strength caused by dust accumulation or moisture absorption, which may lead to insulation breakdown. 3. Maintenance of the cutting power supply. All electrical circuits must have good insulation. The input cable must meet the required specifications, and the cross-section of the output cable must be at least 40% larger than that of the input cable. The iron shell switch and machine body must be properly grounded, parallel wiring. The resistance must not exceed 10 ohms. Check the wiring boards and terminals of both input and output cables. They must be clean and intact, with no signs of burning or looseness. Copper washers on wire ends must be complete, and all bolts must be securely fastened. Regularly inspect the commutator and carbon brushes to prevent rust in the brush holders. In dusty regions, prevent sand particles from entering between the carbon brushes and the commutator to ensure their integrity and conductivity. After each operation, be sure to remove dirt and debris from the machine body, commutator, and carbon brushes to keep the equipment clean and functioning properly, and to avoid insulation degradation or short circuits caused by dust buildup. At the end of each shift, lubricate all pivot pins to ensure smooth rotation and reduce friction and wear. For parts with lubrication points, regularly apply lubricating oil. After every 100 hours of operation, adjust the position of the brush holder and brush frame according to the wear condition of the commutator, and tighten the displacement screws. Check whether all bolts and fasteners are loose or damaged. Alright, that concludes today's lesson. I hope that through this session, everyone has gained a deeper understanding of plasma arc cutting and blanking. As manufacturing continues to upgrade and evolve, plasma arc cutting technology will keep playing a unique role, bringing more innovation and breakthroughs to the field of metal processing. We look forward to seeing this technology become more intelligent and automated in the near future, contributing even more to the prosperity of the manufacturing industry. This lesson is concluded. Thank you for listening.